Swayam Prabha. Digital India. Educated India.
Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you. And this is the TKM2 subject being taught under the NPTEL MOOC, and this is the 30th lecture, which is the end of the 6th week, because you know you have 5 lectures per week and we have another 2 weeks to go. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing the concepts of folds, like as you consider the variables, the fraction factorial models, and what is the best possible combinations of these variables, which will basically give you the idea of the maximum so called prediction. The information set would be the maximum, that means by the using the least amount of variables. Let us consider the resolution of the fifth order of 5 design. Resolutions of 5 design or fifth order are fractional factorials in which the main effects and the 2 factor interactions. So, in whichever combinations you are doing, consider the number of variables is 7, but they each of them are basically combine them in on 2:2 or 2 into 2 time this levels, which means high low for the first one, high low for the second one, and so on and so forth. So, it considers the 2 factor interaction, and they do not have other main effects, and the 2 factor interactions as the analysis are basically done. Consequently, they are very powerful designs, allowing unique estimation of all main effects and 2 factor interactions. So, a main effects obviously would be the main variables which you are considering. So, if there are 7, you will have basically A, B, C, D, E, F, G, and the combinations based on that you find out the effects. So, let me continue reading it. Estimation of all main effects and 2 factor interactions, provided of course, that all interactions involving 3 or more factors are negligible. So, the higher levels combinations you do, 3 factor, 4 factor, 5 factor, obviously their corresponding interaction and their effect would decrease or be as small as possible. The shortest word in defining relationship of the resolution 5 or 5th degree must have 5 letters. So, if you are considering the interaction, so it would be 2 to the power k minus 1. So, k is basically 5. So, designs would be where the overall combined factors or so called indicator variables combined together would be A, B, C, D, E, and obviously combinations would give you the best possible effects. So, continue reading in the same line. So, it is perhaps the most widely used resolution 5 design, permitting study of 5 factors and estimation of all 5 main effects and of the 10 2 factor interaction. In only 16 runs we are able to accomplish that. We will consider the super saturated design. Saturated design is defined as a fractional factorial in which the number of factors or design variables, which is basically k is equal to n minus 1 depending on the combinations, where n is the number of runs which you are going to consider. So, you will basically leave a level of saturation such that the best predictions should be coming out from those discussions. In recent years, considerable interest has been shown in developing and using supersaturated design for factor screening experiments. In a supersaturated design, the number of variables where k is greater than n minus 1, and usually these designs contain quite a few more variables than runs, such that it is very difficult to find out the overall effect which you want to find out. It is like this: if you have a number of variables or number of equations, So, if the number of equations or the number of variables are more as per the requirement, so obviously there would be some redundant equations, or it would not be able to, given less number of equations, we would not be able to find out the exact solutions of the variables, like in the simultaneous equations which you have solved. So, if you have two variables, you will basically have two equations and they are not dependent on each other to give you the exact results of the variables. If you have 2 and if the number of equations are 1, then obviously you will have different combinations of infinite sets of solutions, and it can change depending of if the number of variables is 3, number of equations 2, and so on and so forth, provided these equations are not dependent on each other, not convex combination of each other. So, most design construction techniques are limited have limited computer search procedures based on the simple heuristics based on which we find out the best combinations. Others have proposed methods based on optimum design construction techniques, and so on and so forth. So, we will consider some additional design and analysis topics for factorial and fractional factorial designs, based on which we will basically expand our ambit or the discussion or different factorial models. Now, if you remember, I did mention that the combinations we are always trying to find out is 2 to the power something, so the superscript. So, this 2 was basically the level of interaction each would have with each other. So, plus minus for A, plus minus for B, plus minus for C would give you the high and the low level of the interactions of each factors, based on which you can find out the combinations. So, in the 3 to the power k, k is the superscript factorial design, a factorial arrangement with k factors where each are at 3 levels. So, it can be, say for example, levels rather than plus and minus, I can give you the levels, say for example, as -1, 0, 1, or it can be given as 1, 2, 3, whatever combinations. 3 levels of the factors are here, it is given here, and I will highlight it in order to make you understand. So, these are low one. So, low one, the intermediate one, and the high one. So, initially what you have was basically the plus and the minus. So, that is why we got 2, and corresponding to factors we mentioned it as k, 2 k. Now, consider you have low one, I am using a different color red now, the intermediate one the second, and the high being the third. So, you will basically have 3 to the power k. Each treatment, so let me continue reading it, and that is the third bullet point. Each treatment combination in the 3 k design will be denoted by k digits, where the first digit indicates the level of factors A, the second digit indicates level of factors B, and the kth digit indicates the level of factors k. For example, in a 3 square design, 0 0 denotes the treatment combination corresponding to A and B both at the lowest level, 0 1 denotes the treatment combination corresponding to A at the low level and B at the intermediate level, and different, and 1 1 would be intermediate level. If it is, say for example, given a combination of 2 2, it would mean both of A and B at the high level. It is basically 0 2, it would basically mean that A is at lower level and B is at high level. So, different combinations can come out. Now, let me consider this concept pictorially. So, we have the factors A and the factors B. So, now let us think qualitatively in order to make things very crystal clear to us, and let us assume the diagrammatic representation which will make things much clearer to you. I did mention, not from the point of view of the diagram drawing, but I did mention that if the number of factors combinations is 2 to the power k, 3 to the power k, and so on and so forth, how it should be considered. So, now we will go into the depth. Now, in a 2 to the power k model, I am using the very simple layman words in order to make you understand. So, in the 2 to the power k model, what we have, the factors A would be measured along the x axis, which is horizontal, where I am drawing, I am keeping my arm, and the factor B would be vertical to that, so which is my left arm. So, any coordinate in between this Cartesian space would basically give you the levels of combinations of A and B. Now, if you are considering the levels of combinations of A and B of 3 levels for 2, so basically we will consider level of 0 as low, 1 as intermediate, 2 as high. Then if you draw the overall combinations, what you will have? You have 3 combinations of A, 3 combinations of B, 3 A being along the x axis which is horizontal, B is along the y axis which is vertical. So, you will basically have a grid of size 3 cross 3, that means you will basically have 9 such grid points. What are those grid points? Let me show the diagram and explain that to you. So, in the grid points which you have the factor as I mentioned y being mentioned along which basically denotes B, x denotes A, and if you notice that the levels of significance or level at which they are working for A would be 0, B would be 1, and again sorry A would be 1 and B is A is 2. And in the similar case you have B as 0. I am not pointing writing it, but I am only denoting through my cursor. So, here A B as 0 level, B is at 1 level, B is at 2 level. So, if you consider the combinations, consider this, these are at both low levels A and B. This means both are at the high level. This means they are at the intermediate level. If I consider this, it means that factor A is at low level, factor B is at high level. If I consider this, it means factor A is at high level, factor B is at mid intermediate level. Now, with the same concept, switch to the 3 factors. 3 factors now, if I denote A along the horizontal as my right arm, B along the vertical which is my left arm, and C, if I consider C can be either the axis going towards you or the axis coming towards me. So, basically we have if in this discussion a very simple concept of the 3 dimension, which is a room where the corner of that room is basically the origin, and if you go along one of the floor in x axis, along another of the perpendicular line on the floor is basically the y axis, and the other one which will go horizontally up towards the roof would be the z axis, which are basically corresponding to factors A, B, C. Now, and obviously consider if they have the levels of low, intermediate and high, the overall concept would be again now be a cube. Now, like if you have seen the Rubik cube is basically the cube, and what the combinations are, it will be denoted very simply in the diagram which I am going to show now. So, you have the factor C, low, intermediate, high, factor A, low, intermediate, high, factor B, and all these are orthogonal to each other, factor B, low, intermediate, high. So, this is B. Now, the combinations if you do, you have obviously this would mean it is low for all 3 A, B, C. If you do this, it is high, high, high for A, B, C. If you do this 1, 1, 1, it is intermediate, intermediate, intermediate for A, B, C. If I consider this one 0 to 1, it will basically mean it is low for A, which is factor. I am basically going the sequence of A, B, C. It will be low for A, high for B, and intermediate for C. If I consider 2 to 0, it will basically be high for A, high for B, low for C. If I consider 0 to 2, it will be low for A, high for B, high for C. If I consider 0, 1, 1, 1, 0, it will be intermediate for A, intermediate for B, and low for C. So, in these combinations you have this cube. Now, only thing you may say that why the grid line which I am now going to draw has not been drawn, or let me use a different color. So, it will be much easier for us to understand here. So, this would be one of the grid lines, this would be another grid line, this would be another grid line, this would be another grid line, there would be a vertical drawing here, they would be going here. So, these combinations will give you. So, this is basically a cube. So, hope I have been able to draw it. Yes. So, basically it will have corner points 0 0 0, 2 0 0, 2 2 0, 2 2 2, 0 2 2 and 0 0 2. Other would basically be corner points would be the points 1 2 2, 1 0 2, 0 1 2, 2 1 2. Then similarly in the next level you will basically have the next slice, you will have 0 1 1, then 0 2 1, then you will have 2 0 2 0 2, this we have 2 2 1, 2 1 2 1 1, 2 0 1 and you will have a point here accordingly. So, you will basically, and this will be denoted by 1 0 1. So, similarly, when on the last level 0 0 0 0 1 0, here would be a point given, you have basically 2 0 1 2 2 0 2 1 0 200 100. So, the first figure is basically the treatment combination of 3 to the power 2 design. The second figure which we just discussed is basically treatment combination of 3 to the power 3 design. Power means different levels of any interaction for any one variable. In the 3K system of design, when factors are quantitative, we often denote the low, intermediate and high designs as I mentioned as -1, 0 and +1. It can be 1, 2, 3 depending on what is the level of significance which you want for your calculations. I am not going to go into that immediately details. Let me finish this slides. I will try to give us a philosophical or so called qualitative look that why would you consider -1, 0, 1 and not 1, 2, 3 or any other combinations. This facilitates fitting a regression model relating to the response of the factor levels. For example, consider 3 to the power 2 design and let x 1 represent factor A, x 2 represents factor B. A regression model relating to the response of y being given by x 1, x 2 and a combination of them would be as follows. Y would basically now have the effects of x 1, x 2, x 1 square if it is of 2 levels, x 2 square and the combination of x 1 and x 2. So, x 1 would be linear, x 2 would be linear, x 1 square is basically square level for effect of x 1, x 2 would be square would be effect of x 2 squared and x 1 2 would basically be the combinations which you have for x 1 and x 2 and the corresponding this parameters would be beta naught, beta 1 for x 1, beta 2 for x 2, beta 1 2 for x 1 2, beta 1 1 for x 1 square, beta 2 2 for x 2 square and obviously the error term would be there with the corresponding assumption that the mean value is 0 and the variance is 1 and obviously normality and on all these combinations would definitely hold true. The simplest design in the 3K system is the 3 square design which has 2 factors each at 3 levels. So, consider the levels -1, 0, 1. Because there are 3 square 9 treatment combinations, there are 8 degrees of freedom between these treatment combinations. So, because if you remember we consider it is as 3 to the power k minus 1. So, obviously, the degrees of freedom would be 1 less than the power. The main effect of A and B each have 2 degrees of freedom and the A B interaction has 4 degrees of freedom giving on the combination. Why 4 degrees? Because you have x 1 square combinations, x 2 square combinations, x 1 1, x 1, x 2 and x 2 and x 1. So, mentioning, so continue reading it and the A B interaction has 4 degrees of freedom. If there are n replicates, they will be n into 3 to the power square minus 1 because the replications would be multiplied accordingly. Total degrees of freedom and 3 square into n minus 1 degrees of freedom for the errors and we can calculate the overall problem and the level of degrees, the robustness of the model accordingly. The two factor interaction A B may be partitioned into two ways. Suppose that both factors A and B are quantitative. So, if they are quantitative, the first method consists of subdividing A B into 4 single degrees of freedom component corresponding to. So, what we will have basically the A and B factors are considered and they would be done in a way where you will have basically A B the level of their significance would basically be denoted by the level of different combinations which you have. So, it will mean that A B would be to the size L cross L, A B can be also to the size of L cross Q, A B can also be the size of Q cross L and A B can also be the size of Q cross Q. What is Q cross Q? I am going to come to that. The second method is based on the orthogonal Latin squares. It is usually associated with the case where all factors are qualitative. As an example, let us consider the total treatment combinations for the data which is given in example 5.5. Now, let me pause here. If you remember that I mentioned just in the last slide that rather than taking the factors as -1, 0, +1 or -2, -1, 0, +1, +2 depending on levels being at 5 levels. So, it will may be very high, high. So, this is very high being +1, high being very high being being +2, high being +1, moderate being basically 0, low being -1 and very low being -2. Rather than considering that, why not consider the levels at say for example 1, 2, 3 or 1, 2, 3, 4, 5 and basically do the combinations accordingly, where 5 would be very high, 4 would be high, then 3 would be basically at the level of moderate average, then you have basically 2 as low and 1 as very low. The reason is that the combinations we always consider the mean value is 0 for the errors. Now, it may, but in actual practical case it may not be true, as I will give you an example, but in trying to solve the problem from the theoretical point, it is best that we consider the mean value 0. Even if the variances are same in both the cases, still it is true that considering the values as -1, 0, 1 or -2, -1, 0, +1, +2 would give you better results in trying to find out the prediction level. Considering the assumptions on normality and variance, normality being 0 and variance being equal to sigma square or 1 has to be met, and the average value being 0 is met in the case when you have basically divided the levels at equal dispersion below 0 and equal dispersion of on the positive side above 0. But in the case when you have basically skewed it more towards positive or more towards negative, obviously the mean value is definitely not 0, which is one of the violation of the assumptions. The variance may be same, but obviously considering the assumptions have to be met, this method is not followed. This method means that considering that the overall levels of factors at which they are affecting each other are either skewed on to the right or to the left. Now, let me give you an example and why this. So, this is nothing to do with the discussion which you are doing now, but it will give you a much better idea that how you can practically in a very simplistic sense understand the concept of why different type of combinations in the practical sense and the theoretical sense may not make sense in when you are trying to solve the problem, but when you consider the theoretically we still use the theoretical results in order to basically find out some combinations or some ideas that how we will go into the practical sense. Now, consider that you are trying to build up a dam and the dam actual height should be 120 feet. Now, they consider there are two cases. In case 1, the engineer builds the height of the dam to 122 feet, and in another case the second engineer builds the height to the height of 118 feet. So, the differences are 122 minus 120, and another case the difference is 120 minus 118. So, if I consider the concept of the squared error, which is basically the mean concept based on which we are trying to find out the variances, if we try to consider that, the errors are plus 2 whole square minus 2 whole square, which is 4 in both the cases. Now, what let us, and when we solve the problem, do the estimation, it gives us very good result theoretical sense and we are happy. But consider what happens in the practical sense. In the case 1, when you have built the height to 122 feet, the extra cost of man material is definitely there. But if a flood comes, the propensity of the probability of the flood breaching the dam is much less in this case, because the height is on an average plus 2 than the average height, which should be 120. So, initial cost was high, but the catastrophic loss, the environmental loss, the human being lives loss, the natural calamities loss is very much minimized. But on the case, consider case 2, the initial cost for materials and all these things is definitely saved, but the problem happens that when a flood comes, the propensity or the probability of the flood or the gushing water breaching the dam is much higher. So, hence in the later case, this case 2, when flood happens, the overall calamity and the overall loss is much higher. So, obviously, you have to see that even if we try to penalize the so called estimation of the equal proportions in +2 and -2, yet the actual practical consequences are totally different. That means, underestimating has a huge catastrophic loss. Consider another example and just a diametrical opposite one, where you have basically an electrical circuit, there are huge machines are there and there are electrical circuit breakers or vacuum circuit breakers, and the average life of working of those circuit breakers is, say for example, 6 months, and after each 6 months, which is the warranty life, you want to work on the machine. Now, it may so happen that in case 1 you over predict and basically give it a value of 7, in another case you under predict and you give a value of 5. So, the over prediction and under prediction squared values are +1 whole square, which is 1, and -1 whole square, which is 1 again. But now if you think on the theoretical sense, both the values of +1 and +1 on both on the positive side and negative side have the equal effect. But what happens in the practical sense? In case 1, if you basically are tempted to stop the machine at the time when it is 7 months, then obviously you have done a lot more production with the extra 1 month, which is 6 to 7. But the propensity of a catastrophic electrical breakdown having an effect on human life, production and so on and so forth, or a fire hazard and all these things is much higher in this case, because the propensity of the machine to fail is much higher after the 6th month. But in case 2, you will be tempted to stop the machine at the 5th month, obviously it will have a negative effect on your total production, man-hour loss. But you are rest assured that if you do a servicing of the machine, do a corrective action for all these vacuum circuit breakers at the end of the 5th month, then the propensity of having a catastrophic loss is much less. So, in this case, overestimating would basically have a negative consequence than in the case when we have seen the dam where underestimation was a problem. So, if you consider those type of practical situations and then try to basically understand the concept here, where the levels of importance of any one of the variables, leave aside the qualitative part, the quantitative part, which is the values which you give as -1, 0 and 1, and in another case you give a value of 1, 2, 3. In both the cases, theoretically the values of variances are same, but the concept of averages in one case is 0 and another case is not 0. But in the actual practical sense, it may happen that trying to give a higher score for a level of higher interaction would actually give you a much better picture in the practical sense, but we may not be able to do that on a theoretical level to solve the problem. So, considering this, so the treatments which we considered, the combinations for the 2 orthogonal Latin squares are given for factor A and factor B, and factor A and factor B are given in these combinations, which is factor A has the levels of -3, -3 plus 5 at the levels which you are considering. For 1, the combinations of B and A at levels at 1 and 1, it is considered as 4, this is 4. Similarly, if we consider the factor A and factor B in the levels of 1 and 1, it is 4 here, but different combinations can be found out depending on how you solve the problems accordingly. The 2 factors for A and B correspond to the rows and columns respectively of a 3 into 3 Latin square. So, obviously, it will be 3 and 3, 4 and 4 depending on the level. So, if A has 4 levels, B has 4 levels, you will basically have 4 cross 4. Now, the question would also arise that what happens if I have the levels at A being at 4 different levels and B at 3 different levels. Obviously, you will have a not a Latin square, but you will basically have a rectangle of size 3 cross 4 or 4 cross 3 depending on the levels of such interactions A and B have. In particular, 2 particular 3 cross 3 Latin squares are shown superimposed on the cell total. So, depending on the level of interaction, you will have the cells corresponding to that. These 2 Latin squares are orthogonal, that is, if one square is superimposed on the other, each letter in the first square will appear exactly once with each letter in the second square and corresponding to that. The total of the letters in the squares is basically 18, because it will be the 1, 2, 3, 4, 5, 6, 7, 8, 9 in one square, another 9 in the other square. So, they basically 18. So, R is -2, S is 8, Depending on that, you can find out the degrees of freedom and calculate accordingly. So, with this I will end the 30th lecture and continue discussion more about fractional factor and higher orders of interaction for higher levels of factors accordingly, and discuss it in more detail. Have a nice day. Thank you very much.